Now, here's where we get to the fun part. Please search for articles on this disease. I'm not going to say it again. I feel like I embarrassed myself enough trying to say it. This is where you'll see the DuckDuckGo search is initialized, right? Only because we used the key word. So, for example, if we do please include. What's going on, everybody? Welcome back to another Granularity AI tutorial. Today, we're going to talk about a little bit of a side project that I've been working on myself that involves two things: agentic AI and semantic caching. Now, I think agentic AI might be something that a lot of people might have heard of. It's not really that new of a concept. I think agentic, if you're familiar with AI agents, you've heard of agentic AI being thrown around and the theoretical concept of it and how to possibly implement it in different use cases. And I devised a process, some logic that takes a large chunk of what someone else has already created in Hugging Face, and then adding my own spin to it. We'll kind of dive into that in a bit. But if you are interested in agentic AI or learning about semantic caching, please make sure you like, subscribe, dislike if you feel like it. All I ask is that if you do decide to dislike, add some feedback, add some suggestions, add some comments, so that we can still provide to you the best content that you're asking for, really. But yeah, don't forget to subscribe and like. So, agentic AI, what is agentic AI? Agentic AI refers to AI systems that operate autonomously, making decisions and taking actions to achieve specific goals with minimal human intervention. These systems can plan, reason, and adapt dynamically by interacting with their environment, other agents, or external tools. By leveraging techniques like reinforcement learning, retrieval augmented generation, and multi agent collaboration, agentic AI enhances problem solving and task automation across various domains. If you've seen my past tutorials that involved RAG, I believe with both corrective and adaptive RAG, I think corrective might be a corrective RAG might not be too much agentic capabilities, but adaptive RAG definitely agentic. It's a theoretical kind of process that can be used in various domains. I don't know too many um, enterprises that are using adaptive RAG right now, but it's a concept that is kind of getting popular. But the main point of view when it comes to agentic AI is having AI being able to run into an issue or having a process logic running into an issue and then being able to use tools to address that issue. If you are familiar with RPA, I know RPA, I think um, at this point might be losing in popularity. I think there are certain companies that are still trying to keep our RPA alive. If you're not familiar with RPA, it's robotic process automation, but Power Automate, I think, might be a concept of RPA. UiPath is like the biggest, I think, RPA um, company out there, and I think maybe Zapier might be one as well. I'm not 100% sure, but I've worked with UiPath some in the past, and RPA I don't think is necessarily going to die out or anything like that. Like I think there will still be RPA developers needed, but it's just going to be RPA integrated with AI APIs or tooling. Like it wouldn't it yeah, it's not that it's gonna dissolve and companies are gonna dissolve and things an RPA is gonna lose its popularity. I think it's just gonna probably integrate with AI tools and still be RPA. But anyways, That's agentic AI. The concept of when you do have RPA or RPA versus agentic AI, RPA needs rules. RPA needs rules to whoever and encounter something to know how to solve it. And you have to manually state these rules. And if the RPA encounters an error that it has no ruling for, it essentially just kind of breaks down. Whereas with an agentic AI, if given the proper tooling, if it does encounter an error, it will think through it or maybe reason through it, hopefully, and move on versus like kind of breaking down and now someone, an engineer, has to kind of step in and fix things. Instead, agentic AI can kind of handle things on its own. So that's kind of a surface crash course on agentic AI. Semantic caching. Semantic caching is something that's fairly new for me. I think I heard about it maybe like I was at a Redis. If you're not familiar with Redis, I think it's like a database platform. I'm not sure. Someone can correct me in here in the comments. But I think it's like a database platform, caching platform kind of thing. But I was at a Redis webinar, and the concept of semantic caching came up, and I thought it was really cool. So, semantic caching stores query embeddings in a vector database, allowing efficient retrieval of semantically similar responses. When a new query is made, its embeddings is compared to cached embeddings using Euclidean distance, which measures how far apart two vectors are in the embedding space. A smaller Euclidean distance indicates high similarity, enabling the system to return a relevant cache response, while a larger distance triggers fresh data retrieval. So think of it like this as to why semantic caching might be important to engineers, developers, AI engineers, enterprises, businesses that are focusing on these AI tools. As we know, over the time horizon, right? Um, as LLMs, as AI becomes increasingly more and more intelligent uh, and more efficient, the cost becomes less and less, right? Except for like reasoning models, I think those probably will remain like not expensive, but more expensive than like using a GPT 2 or 3.5 or some early LLM model. But with that being said, if you are in an enterprise or if you've made a chat tool or an LLM tool that's maybe just a wrapper around OpenAI's GPT models or Claude's models or Google's models, Meta's models, whatever it may be, I don't know. And let's say you have a plethora of individuals using this API, right? You have a plethora of individuals querying this LLM, and it could go from maybe a few hundred to a few million of queries per day or per week. You don't know. The point I'm trying to make is that cost, no matter how cheap it is, can rack up, right? You may think, oh, 6 cents here and there, it's 6 cents, who cares? I promise you, the more you let it get away from you, the more disappointed you're going to be when you have to pay for using that API. You might think it's a small feat, but if your tool is super efficient, super useful, super productive, and let's say you roll out this tool, you scale it to maybe having 1 million subscribers or tens of millions, whatever, how many millions, having these millions of people, even hundreds of thousands of people querying this API constantly can rack up in cost. So semantic caching comes in, right? And I think this is very important in kind of being more efficient and eliminating how much cost is the vector, the semantic caching stores embeddings in a vector database and will decide based on the Euclidean distance whether or not it should hit the API or formulate a brand new response. Now imagine, let's say you work in, I don't know, some customer service based business. Usually there's a frequently asked page of questions and answers. And now I think presently we have chatbots, right? Rather than your chatbot constantly hitting the API over and over again for the same questions that 30,000 other customers might ask, why not just have the chatbot or incorporate semantic caching into your chatbot to then just use the same common answers to fairly similar questions of the same concept, right? This way, you don't have to add more money to your already AI budget of how much you got to spend on APIs or on LLMs and how often you use these LLMs. You instead have a process where you can direct frequently asked questions to the semantic caching. It doesn't hit the API. Instead, it just reuses, recycles past answers for similar questions. And in those cases where it's a fresh, brand new question that the cache isn't familiar with, or the vector DB isn't familiar with, it instead generates a whole new answer. In this also, in the project that I was building, there was in Hugging Face, let me move my face over here, implementing semantic cache to improve a RAG system with FAISS by Paramatra. Super insightful link. I will include this link into the description for you guys to check out. But super insightful post. Really loved it. Highly recommend reading it and check it out. But one thing that I thought this was missing in Paramatra's logic was, okay, semantic caching is cool, right? It's cool to know how to incorporate it, how to load the data set, how to experiment with Hugging Face data sets, stuff like that. Like, all of this is very useful stuff. But I want to include some type of agentic way where the limitation in this was if it didn't meet something in the cache, right? It was not able to answer it. It wasn't able to answer it comprehensively. And also, maybe the answer I'm looking for wasn't even in cache in the first place. So we're all familiar with ChatGPT's search option, right? I think not all, but some of us, hopefully. If you've seen it, it's right next to the reason button. Sorry for moving my face so much. I'm looking right at you, there is a search option in ChatGPT that can be used, where it searches the web for you. Now, before that search option, that search button was there, I noticed that there were certain keywords, and even I think now still, there's certain keywords that have to be stated in order for ChatGPT to perform the web search, right? You might use like search, or use the web, or look online, or look for, or I don't know, something like that, right? Using certain keywords will then activate the Agentic AI, the tooling, to then go search on the web for whatever information you're looking for. So I was like, why not incorporate this into what I'm doing? So shout out to Para Martra. I hope you see this video. Your Hugging Face cookbook was extremely helpful. Um, yeah, if you see this video, extremely helpful. Great documentation. I'm gonna click on. Let me see if I can find great documentation. Engineer, deep learning specialist pursuing da 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 da. Author of cool. I might actually. I'll check out this book. Anyways, reach out to this guy, get some more information from this guy. But anyways, besides that, let's jump into the code. If you are interested in what I've been talking about for the past 15 minutes, I'm sorry if I do too much talking. I know some of you just want to jump right into the code. Please make sure you hit that like button, hit that subscribe button, hit that dislike button. All I ask is that if you do decide to dislike, make sure you comment, make sure you leave suggestions, make sure you leave feedback so that we can provide you the best content we can. Um, we're not sensitive. We appreciate constructive criticism as long as it's helpful. So, yeah. Anyways, let's jump in. So, again, I will include the semantic caching documentation from Hugging Face that I found in the description. If I forget, let me know in the comments and I'll throw it in there. But you want to install some packages first, right? I'm not gonna kind of code it out all for you guys just because it could take a while, frankly. So if I coded it out, this video would be way longer. But if you do appreciate the like complete coding tutorials, let me know. This code will be on the Granularity GitHub. Check it out there. You can definitely use it yourself. I'm using Google Colab. It's easier to use than maybe like a VS Code or a Jupyter Notebook. Sometimes you got to manually update or install new versions of Python, new versions of Jupyter in order to kind of get these things running. Google Colab is kind of easier, where it searches for the particular packages you need. Sometimes I think it goes for the sentence transformers. It need like the Chroma wheels installed, I think. I didn't have that on my Visual Studio. I didn't have that on my Jupyter, so I decided to use Colab, and it works fantastically. So I believe for this case, I've also done this in Databricks. It works fine for all the ones who are engineers and developers out there. But just for this, I'm using Colab for my own personal stuff. So yeah, transformers, accelerate, sentence transformers, ChromaDB datasets. Datasets, transformers, and I think sentence transformers are specifically from the Hugging Face documentation and API. I believe transformers specifically in datasets go with Hugging Face. Torch, I believe, is for PyTorch. It's from Google, I think. Pretty sure PyTorch is from Google. And then we have FAISS, LangChain Community. I was planning to use the Tavili Python, didn't feel like it wasn't working right. So instead, I just used DuckDuckGo search. If you are familiar with LangChain and their tooling, you are familiar with DuckDuckGo search. DuckDuckGo search is a free tool, free web search tool that can be used with your AI agents when it comes to having agents explore the web for doing research or stuff like that. I'm pretty sure I wouldn't be surprised if like tools like Perplexity AI uses stuff like this. But DuckDuckGo search, highly recommend. It is free, no API key needed. But Tavili and I think Serper do need an API key. But LangChain here as well. Let's keep going. So bunch of packages, pandas, GetPass for keep my Hugging Face API key secret from you guys, all you stolers out there. ChromaDB, Torch, Transformers, LangChain tools, stuff like that. I don't think all of these are needed. Maybe I might have a cleaned up version of the packages I use. But I'll see when I load it in. The medical Q&A dataset loaded in from using Paramatra's um, tutorial, and this is how the data set looks. Who is at risk of lymphocytic? I don't know how to pronounce that. What are the symptoms? Da, 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 da. So this is kind of just taking a look at the data set provided. Who is at risk for parasites? Cystocirrhosis. How to diagnose parasites, cystocirrhosis. I don't know. Made some graphs from it as well. And again, these graphs, I thought this was super cool. Just a side note. These graphs, I did not generate. This was all from Google Colab. So even right now, I am looking into the novice data scientist in me is looking for um, different packages out there that can help me automate exploratory data analysis. I think Pandas AI was one I did in the past, but there's so many others out there that are pretty interesting. So highly recommend. Maybe I might do like a post on them or something at some point in the future. Who knows? Looks like it made some violin charts. I think these are violin. Uh, I don't really want to run these, but anyways, um, you don't want to use the whole data set. Also, I want to add that. I think here you kind of want to do the split and add the train command here so that you don't end up using for who knows how many questions are here. I'm not entirely sure. I didn't do a count. Um, Max rows 1,500, 15,000. So who knows how many kind of rows are in that data set. I wouldn't try and see if you can use all of it. But then we're going to load it to this ChromaDB persistent client. You don't, unless you want to, you don't necessarily have to use your own directory. This path to persist directory is kind of already there. You kind of just need to use it. So yeah, unless you have like your own directory you want to use, sure, go ahead. I didn't. It's up to you. And then once you kind of have this loaded into a collection, I just follow whatever was in the tutorial originally in this news collection piece. Collection add, blah, blah, blah. You're querying the database function, cache function, retrieve cache function, store cache. Here is where we get to the juicy bits. This is another reason why I didn't want to write it out all by hand for this tutorial because it would have taken a long time. So here we have the entire semantic cache class. Now, I didn't change too much from what was in the documentation here of this implementing semantic cache from the original author, but I also didn't use this Tavili search thing here. But anyways, what you want to pay attention to is the self.search tool DuckDuckGo search one. This here is incorporated once we get to the ask definition, which we'll run down in a bit, where there are certain keywords I implemented: search, find, look up, look for, Google, similar to ChatGPT, where again, this might have been either before. I don't think they have this. The search button is fairly recent. I think they had to have incorporated maybe like end of last year or beginning of this year, where before the search button was there, you had to use certain keywords, which I've incorporated here. You'll see how it functions in a bit. But here is where we incorporate keywords: search, find, look up, look for, Google. My also thought to this is there would have to be like a corpus of certain keywords for the AI to look for, or for the AI, or for, that would trigger the search tool to be used. Um, when it runs into these keywords. But anyways, I don't want to go off on too much of a tangent and start thinking. But we incorporate these keywords here, using DuckDuckGo search to do to detected keywords, blah blah blah. No relevant found in DuckDuckGo, asking ChromaDB, no relevant information found. Here's where it outputs the search results here in this DuckDuckGo search results, blah, blah, blah. The rest of it copied from the original author. Um, that's kind of the only key piece that I was kind of proud of. Everything else was used by the author, but that's kind of my own little flavor on it. Handle case, there are not enough yells, or no, I'm not. I'm asking to ChromaDB. Search for nearest neighbor in the index. This is also important. Let's keep going. So here's where you initialize the cache itself. Uh, at the end, you'll see also where you get to incorporate your own specific model. Not your own, but a model that you might find on Hugging Face that's open source. Blah, 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 blah. So here's where we get to asking the question to the cache logic we created. So we see here, how do vaccines work? It's a kind of direct score, meaning like it was damn near related closely to whatever was in the cache already, and it just kind of definitely reused an answer from the past. Briefly explain to me what is Sydenham Correa in 20 words. Um, this is where you want to get as close to zero as you can, basically. The closer to zero you are, the better. Um, so, with that being said, briefly explain to me what is Sydenham Correa Correa in 20 words, and you'll see that it has a score of 0.244, meaning it's pretty far from whatever is in the cache, um, and may have to generate a brand new answer or include kind of a brand new kind of formulate kind of a mixture of different answers to questions from the cache to be used, or it might have just taken something directly from the cache that might not be exactly close to what the user is asking for. For example, in the 20 words piece, you'll see that it obviously included more than 20 words, as you see here. So it didn't answer it directly, but I mean, it did explain what Sydenham Correa is in it did briefly explain it, just not in 20 words. Now here's where we get to the fun part. Please search for articles on this disease. I'm not going to say it again. I feel like I embarrassed myself enough trying to say it. This is where you'll see the DuckDuckGo search is initialized, right? Only because we used the key word. So, for example, if we do please include articles on Syndem Carrera, what I'm banking on is that it end up uses Chroma. So answer recovered from Chroma. There is no standard course retrieve for Carrera, blah, 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 blah. It didn't include any articles, right? There's no reference to articles. It just says there is no standard course retrieving for this disease. But when we use, I think, let me see the keywords. I think it was find. Let's use the word find. Please find articles on this disease. It should, again, resort to using DuckDuckGo. Findings in children, blah, 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 article in Italian, blah, 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 blah. So it brings back information directly from the web on this question. Let's try another question. Please find articles on bird flu. Bird flu in 2024. Let's see what it brings back. Published, blah, 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 December 24th, 2024, link copy, da, 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 da. So it again, took answers directly from the internet. So this is what I'm saying, like, let's just say there's no way to answer the question that a user poses, or maybe the query that a user poses is completely out of the realm, out of what's in the cache already, completely out of the realm on what is what the LLM has in its corpus. the logic should be able to say it doesn't meet what's in cache. It doesn't meet information that's in the LLM already. Last resort is to go search the web. That's the process that I'm thinking. And maybe this could be a larger project in of itself, right? A whole larger chatbot. And again, but this is agentic AI in its infancy, right? I don't want to say it's full blown, but it's able to make the decision on its own of, oh, I see this word, or I don't have this within cache. Let me go ahead and find this using the internet. Again, it's not agentic AI where we have to automatically believe where it's supposed to. Agentic AI is in its infancy. Like I said, it was fairly recently when OpenAI included the search option in its ChatGPT UI. But implementations like these, similar to ChatGPT, where because of certain keywords, the logic's able to recognize, okay, go search the internet for this. Or okay, this is way out of what I have in my tooling, or there's certain words I notice that, oh, okay, I need to search online for this information. I think next step would be to see, like, maybe you could include an LLM in this to, and again, this might be where you kind of have to have an LM scan or an agent scan the cache itself and then decide, um, like, oh, okay, it's not here. Let me use this tool to then go ahead and search the internet. I didn't include the scan in this. I just included where adding a bit of search can definitely change how your chatbot operates. How the chatbot operates when it encounters certain questions. So this CUDA, this kind of is something I think CUDA is from NVIDIA. Um, and here is where we include the tiny llama. Now, something that I've been excited about is small language models. I am vehemently researching how to build small language models in my own free time because I'm very inspired by like these tiny llama models. I think it's super cool, super important, and I think more people should be designing these smaller models, small language models, because I believe they're the future. I believe agents plus small language models equals task specific productivity and efficiency. Right now, using a large language model for an agent that does a simple task makes no sense. There's no point. But having a small language model for an agent specifically for certain tasks where it doesn't deviate from those tasks or is very specialized in those tasks can be something super duper helpful in healthcare, in I would say even automotive industries. Honestly, I would say manufacturing industries. I would say customer service industries, engineering industries. It could be super duper helpful. So I want to learn how to build my own tiny or small language model. But anyways, we get to the point where we want to incorporate an LLM into how these responses are generated. We don't want it to take questions directly from the cache, similar to like what you see here, where like you can have it say, "Oh, explain this concept in 20 words." Cache doesn't get that, right? It only knows, "Oh, I see this query. This query matches something within cache semantically. Let me pull whatever super similar to it and include it um, into the response, or just make that the response itself." Here's where we include the LLM to have it more, to tweak it to where it sounds more to where it can sound however we want, whether we want to be more professional, whether we want it to be more succinct, concise, comprehensive. This is where the prompting for the LM comes in. So we have Please summarize the results using the relevant context and the user's question provided. So we have here where I had, please find articles on bird flu in 2024. Um, Now, by taking the context it provided here, the results it provided here, it's going to formulate where it's going to be able to summarize the results it found from the online search it performed based off the question and the results that it has. So we have here, let's run this, boom, boom. And then what should happen, what should happen is we want it to be summarized. So here would be the original, this is something different, but here would be the original context. Here would be the original question. And this right here would be the output that we want. So as this is running, please make sure you like, please make sure you subscribe, please make sure if you feel to it, dislike. All I ask is that if you do dislike, make sure you leave feedback, make sure you leave comments so that we can understand what we were missing and what mistakes we made to kind of make our content better. Where can you include a process like this in your own development? Number one is chatbots. Including something like this in your own chatbots that are powered by an LLM can not only reduce latency by having a response like that, if it's similar to what's already been asked before, it can reduce latency, as well as reduce the amount of cost that you incur, because now you're simply just recycling past answers to frequent questions, and the model will or the logic will understand this. And again, just recycle answers. So not only do you have fast output, but you also become more cost effective. And thirdly, you also become more productive, where you don't need, in the time that it takes to, or the chatbot becomes more productive, right? Where, I shouldn't say productive, more intuitive, more able to problem solve roadblocks, right? Where it encounters a question or it gets a question that through certain keywords, it can find, oh, you know what, this might be out of the realm of what I'm familiar with when it comes to, let's see, blah, 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 blah. User's question, please find articles in bird flu, provided the context, blah, 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 blah. Okay. Anyways, sorry. But yeah, in this, right, through certain keywords, right, it's able to find, to look up, to look for, to do whatever when a user presents a query that has those keywords in it. And sure, the process needs more work when it comes to, oh, okay, well, what if like you use those keywords and maybe it is in semantic caching? Understood. That's where agents can come in to then scan through your cache and say, oh, okay, this is not within the cache. Let me go use DuckDuckGo tooling to search for the answers if I can't provide any. Again, same thing was happening with ChatGPT early on when it was kind of incorporating tools into its UI, where it would based off certain keywords, it wasn't perfect, but based off certain keywords, it would then know, okay, if this person mentioned web, or if this person mentioned search, or if this person mentioned find or look up, or Use Google. I don't know. Mention certain words. That's when it performed the web search. Same concept as here. But anyways, um, please summarize the result. Da, 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 publish. So it has the results here. The user's question is, please find articles on bird flu in 2024. Provided the context. The article is about the current outbreak of bird flu in the United States. The article mentions that the current outbreak began in late March 2024 with the detection of H5N1 bird flu in dairy cows, followed by the first human infections at the beginning of April. The article mentions that over the course of more than 9 months, there have been major response accomplishments in monitoring, testing, viral surveillance, and characterizations, work protection, and animal health. The article ends with a warning about the pandemic potential of the virus. So it didn't give us the context provided here for as long as it is from the DuckDuckGo search. It did a great job of summarizing it to here versus using all the rest of this. So I think it's a well accomplished job, honestly. But this would be something to take that response and just incorporate it into your chatbot from the web search itself. Now, I know we're at 40 minutes. If you enjoyed this video, it was a longer one than I think I've put out recently in a while. If you enjoyed this video, please make sure you like. Please make sure you smash that subscribe button. Please make sure you dislike if you want. All I ask is that if you do decide to dislike, please make sure you leave feedback, suggestions, constructive criticism. We want to hear it so that we can provide you the best content we can. Now, with that, all I have to say is bye-bye.